Okay guys, in this video I'm going to be going over the mechanism for acid catalyzed hydrolysis of esters. Break it up into steps and we execute. Step 1 is going to be the acid-base reaction between HCl and water. Establish partial charges, define who's the nucleophile, who's the electrophile. HCl. The electrons are pulled towards the electron thief, the electronegative atom. Then we go to the other reagent. We have water. Water has lone pairs. It can take a lone pair because lone pairs, electrons, are the driving force of organic chemistry. Go 2 in, hit the hydrogen. 2 out. Break a bond between HCl. You get H3O plus. Oh wow, what is this? It's a proton source. So back to our original starting material. The chemistry is only going to be occurring around the ester. So forget about the other stuff. Forget about it. Define it as R. Step 1 is now protonating the carbonyl group. Boom! 2 in. The carbonyl oxygen now becomes positive. A really good question to ask here is, okay, well, why did the purple oxygen not grab the proton? Let's look at resonance. Every single question in organic chemistry can be answered with resonance. What does resonance tell us? 2 in, 2 up. Oh wow, the carbonyl oxygen is technically a little bit negative. The purple oxygen is a little bit plus because in one of the resonance structures, it's plus. So who's more nucleophilic? The minus-like thing. Carbonyl grabs the H. So now the carbonyl carbon is crying for help. It's so delta plus because the oxygen that's positively charged is pulling as much as it can towards itself because it's electronegative and it's greedy, so it wants those electrons back. It does not want to be positive. But remember, the carbonyl stole a hydrogen from H3O+. So we got water around in solution again. Water is a nucleophile. It is small. It has lone pairs. Hence, it can attack the delta plus thing. 2 in. I bonds are weaker than sigma bonds. I bonds break first. 2 up onto the pink O. Now we got to do a proton transfer. Who's going to grab the proton? The pink oxygen or the purple oxygen? Think about this situation. You are standing at a light post. You see a $5 bill 5 meters away from you. 100 meters away from you, another person sees this $5 bill. You guys lock eyes. You look at the $5 bill. Who's going to get there first? Hopefully you, because you're closer to it. So it's easier for you to just lunge and grab it. Who's closer to the proton? The purple oxygen is. Hence, it is going to grab that proton on the positive oxygen. 2 in, 2 out onto the O. Now we got a leaving group. We also know we need to regenerate the carbonyl group. So take those 2 electrons on the pink oxygen and go 2 in, look, 2 out, boom. Final step is just deprotonating the carbonyl group. 2 in, some base, 2 onto the carbonyl, bada bing, bada boom, neutral. Now you have both your products, but you just have R1 and R2. So go back to the beginning and fill in R1 and R2. You have your products. That's it, that's all. Let me know if you have any questions.